Hey everyone, I'm Joshua Deemer, and welcome back to our Java programming tutorial series. Let's get right into the lesson today. Alright, so last time we discussed binary and hexadecimal and how they work. Well, now let's take a look at some actual data types inside of programming. These are whole number data types, which means they all accept numbers such as like the number 1 or the number 100, but the difference in them is their size. So for example, a byte is 1 byte large. A short is 2 bytes large. An integer is 4 bytes large and is the most commonly used. A long is 8 bytes large. Okay, so what does that even mean? Well, we talked about last time how 1 byte goes up to 255, correct? So that means bytes can go from 0 to 255. And last time we also talked about how, let's say for example, we have this, right? This is 2 bytes here. And it's not going to be 2 plus 0. It's instead going to say compound on each other, okay? So this is 256, this is 512, this is 1024, and it continues going up. So this would be 512, which is above what a byte can handle, okay? So we would need something bigger, such as a short. A short can handle approximately to 65,000, okay? So an integer is the same way. It's 4 bytes large. I'll just do 2 underscores to represent a byte. So it's 4 bytes large. It means it can handle much larger numbers. So that's 0 to approximately 4 billion. Okay, so 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's billion. Yeah, that is billion. So the long is 8 bytes. A long can handle something much bigger. It ranges from 0 all the way to 18 quintillion. That's big. So that's a pretty big number, isn't it? So we got quite a lot on our hands that we can work with in terms of whole numbers. However, keep in mind that we cannot, let's initialize something really quick. Let's say it's 200. This is not valid for a byte, okay? And the reason being is because it's outside of range. But how is it outside of range? We have 0 to 255 numbers, right? It's incorrect. Well, it's correct in the sense that we have up to 256 numbers because if you count from 1 to 256, that's how many there are. So we do have 256 numbers available, yes. But that doesn't mean that's what we have. We actually have negative 127 to 128, I believe it is. We'll verify right now. Okay, it's the opposite. It's flipped around. So negative 128 to 127. The reason being is because with whole numbers, how the bytes work is, let's say we have this, okay? All zeros. Let's make it 2. So this equals 2, right? Well, if we basically have these numbers to work with, and this bit right here represents if it's a negative number or not. If it's a 1, then it's a negative. If it's a 0, it's a positive. Okay? So that's why we only have from negative 128 to 127. Alright? So a short is the same way. We don't necessarily have the 65,000. We instead have negative 32,500 to 32,500. An integer is the same. We have negative 2 billion to 2 billion. The same here, negative 9 quintillion to 9 quintillion. These are the actual numbers that you can work with here. And you can also see what type or how big it is by typing in capital B byte dot max value. You can see right here 127. If we go and do that to short and get its max value, it's approximately what I said, 32,767. If we go to integer, it is 2.1 billion. If we go to a long, then we've got 9 quintillion. Very big number. The next data type category that was coming up is for decimals. So obviously sometimes we want to work with some decimal numbers, right? So a float is 4 bytes big and a double is 8 bytes big. And that's usually the most commonly used. Doesn't mean that everyone only uses doubles, however, it is commonly used. So the way that a float and double works is a little bit more confusing and not as straightforward as whole numbers. So what they have is 1 bit for the sign, so a positive or negative. Then the float has 7 bits for the exponent. Okay. Then the remaining bits are the actual significant digits in a number. Okay. So you can have, I think it's something ridiculous such as the 45th decimal point on a float, and somewhere along the lines of the 300th decimal point for a double. So we also have the character data type, which can be 1 to 4 bytes big depending on the character set that you use. For example, the default in Java is UTF-8. The 8 in it refers to 8 bits, which means that it is 1 byte large for each character. UTF-16 is 16 bits, which is 2 bytes. And UTF-32 is 32 bits, which is 4 bytes. A Boolean is just simply a true or false value. It is 1 byte large, not bytes, byte. It's 1 byte large. All it is you're just saying something is true or something is false. So these are the default data types for Java. The vocab word that we use for this is a primitive data type. There are many more types in Java. In fact, you can make your own types if you want, but one such one is a string, which is a string of characters. Okay? While a char is a character, it can only have 1 character at a time. Okay? And it cannot be a string. Alright? Java is peculiar about that. It's picky about that. We'll go over that soon. But these are the primitive data types. Before we delve into actual code, let's talk a little bit of what the word syntax means. Syntax is essentially a sentence, grammar, inside of code. There's certain rules to it, so let's cover the rules really quick. The first syntax rule is with initializing a variable, and that is the type name equals value semicolon. Let's go ahead and see a real-life example of this inside of code. So here I have some code. And you can see that it follows the syntax for initialization. We've got the type name equals value semicolon. We got the type, which is an integer. You can always change this to something like byte, short, float, double, boolean, right? But you'll notice that there's a red squiggle underneath this 100. And it says type mismatch cannot convert from int to boolean. It's because a boolean must be a true or it must be a false. Alright, so the value must always reflect the type. Always. So we have, let's say we have int name equals 100. So now there's no problem. If we have 5 billion, wherever 5 billion lies, you'll notice that the literal is out of range. And so if we type in long here, there's still an error, but we can convert it to a long by adding an L to the end. And now it's perfectly fine. So the value must always reflect the type. And you can see that name can be whatever I want it to be. It can be name2, it can be random gibberish, whatever you want, but you should always make sure that your variable name is something that makes sense. So name didn't make sense before, but what if I said age equals 21? That makes a lot more sense, because now we can store the number 21 inside of the variable name age. The only thing that names of variables cannot be is having a number at the start. You'll notice there's a underlined squiggle, but numbers can be anywhere else within. It cannot be at the start. It can also not just be a number, because this, firstly, doesn't make any sense. 2 does not equal 21. It just doesn't make sense. So always name it something that makes sense, but don't name it a number. You also can have underscores and dollar signs inside of your variable names, but other types of special characters are not allowed. Only those. Alright, now that we know this, let's go ahead and make some variables to track our age, if we graduated, our GPA, and the final class grade. This should be pretty easy. We could say int age equals 21, following this type name value, okay? Or we can say byte age equals 21. This is okay as well, because we know that we're never going to go above 127. I don't even think there's anyone that is older. I think the oldest person alive was 122 on Google, so we are perfectly fine to use a byte. We could use a short, or we could use a long. No problems with any of those, but we'll use the most common, which is integer, age equals 21. Now, how do we track if we've graduated or not? In fact, let's use my actual age, which is 25. How do we track if someone's graduated or not? Well, there's only two options there, so we can use a Boolean. Okay, so a Boolean, we'll call it graduated. And we can say true or false. I have graduated, so I'm going to say true. Now keep in mind, Java is very picky about your capital letters, lowercase letters. You must have it spelled case sensitive. Okay? That's the same over here. If you have a capital L, there's a big problem there. Alright? Now, let's track the GPA. Let's make it a double. We could also make it a float if we want. I'll show you float first. So float GPA equals, and let's say I was a smart cookie and I got a 4.0. You'll notice there's a red underline. And it's because it cannot convert a double to a float. It's because double is most common, and so we can convert it to a float by typing a lowercase or an uppercase f. It's your choice this time. This one's not case sensitive. Alright, so this converts it to a float. If we want to just make it simple and leave it as a double, you can. You can also, since this is a 0, you can cut off that 0 and just say 4. Otherwise, you can say 3.95 or a 2.2. Whatever you want. But just because it's easier to say 4.0 in English, I'm just going to keep it as 4.0. Now the final class grade, we'll just say that that is our capstone. Okay? So our capstone grade, final grade, is equal to, now we use our single quotes, our apostrophes, and inside of there, I got an A for the final grade. And you'll notice there's still a red squiggle. It'll say syntax error, insert semicolon to complete local variable declaration statement. And it's just warning us that we're not following the correct syntax. And we need a semicolon at the end. Okay? You'll notice a lot of yellow squiggles. It's because we're not using the variables. It says the value of the local variable is not used. And that's true, we haven't used them, so we can ignore those warnings. Warnings are not critical, but they do let you know if something's wrong. Now, before we move on to reinitialization, let's go ahead and talk a little bit more about rules with initialization. Keep in mind that you cannot initialize something that has already been initialized. So since we already have a variable named a, there's now a red squiggle that says duplicate local variable. And so you can click this if you want, and it'll rename it to a1 for you automatically. But just keep in mind you cannot reinitialize the same variable name, even if it's a different type. Okay, so your names must be unique to the current scope. Now, scope is anything within these braces. All right, we'll cover those braces more in the future, so don't worry about it. But for now, just remember duplicate variables is a very big no-no. All right, the second thing is that you cannot name a variable a keyword. So you'll notice that we used int, and that is an orangish brown. We also cannot name it int because that is a keyword. We cannot name it public. We cannot name it void. As you see up here, there's public and void. We cannot name it those. We cannot name it final either. As you saw before, final is a keyword if you were paying close attention. We can't use class. All right, what you can do is you can instead say $class, and that's fine. But you cannot just straight up say class. That is not allowed. So for reinitialization, the syntax is a little bit simpler but very similar. It is name equals value. Let's go ahead and see how this looks in actual code. Alright, so now we can see that type name equals value, our previous syntax for initialization. To reinitialize, we use our name equals value. So here I've initialized an age, but I'm not 0 years old. So later down the road, maybe I want to change that. So let's say now age equals 25. There's no error because we've already declared an age. Now we're just simply restating what the age is. We're setting it equal to something else. Okay? You can do this with every single data type. If you say character A equals A, and you say A is now equal to B, there's no problem there, although this might get a little confusing down the road. I highly encourage you not to use encrypted words and meanings for your variables. Make it very easy for people to understand. Okay? You can also do this with a Boolean. Or you can always set it to the same value. It does not matter. You can do this however you want. Okay, let's go ahead and do some examples. So, if you want to do this on your own, feel free to pause the video and do it now. You can keep track of them up here, where it's the type name equals value and the name equals value. But now we're going to go over it together. So keep track of your age. We'll make it a byte this time and call it age equals 25. Now it says reinitialize to be 3 years older than you currently are. So let's say age equals 28. Okay. Next one is keep track of your favorite dollar amount under $10,000 to the nearest cent. So we're going to say double dollar is equal to 4.56. That'll be my favorite dollar amount. My least favorite dollar amount is negative 10,000 because I don't like having negative money. Then we have keep track if you are happy or not. So Boolean happy equals true. I'm happy. Then it says reinitialize to if you're sad or not. Happy equals false. No, I'm not sad. I'm happy. And keep track of your favorite letter in the alphabet. So char favorite is equal to, and it's going to be J because that is my first letter of my name. And my least favorite, I could put J again because I'm an oddball. Alright, so now I've initialized and reinitialized. I've declared and redeclared these variables. Alright, hopefully your guys' looked similar to this if you did follow along. So you can see here that age, dollar, and favorite aren't as confusing, but happy is. I'm happy, but now I'm suddenly not happy. But even though technically we're saying that this is are you sad? So remember to make sure you name your variables accordingly so that it makes sense now and in the future of your code. That's the end of this episode. Next episode, we will be covering standard and binary operations in Java. Thanks for watching. Feel free to comment what your thoughts are on this series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!